Alright, today we're going to talk about section 4.4 and trigonometric functions of any angle. Now, by now you should be significantly comfortable with the fact of the values of the sine and cosine for all of the key angles on the unit circle, not just in quadrant 1, quadrant 2, quadrant 3, quadrant 4 also. We're going to talk more about those as we go through, but specifically, if you don't know quadrant 1 yet, you are behind. You need to get those, make sure you know those, and we're going to move those around and use them for what we're dealing with now. All right, in the last section we evaluated trigonometric functions of acute angles, such as this was in 4.3, which we did in the last unit. So we did these type. This one right here. The point P of xy is a point. R units from the origin of the terminal side of theta. The right triangle is formed by drawing a line segment from the point perpendicular to the x-axis. Note that y is the length of the side opposite theta, and x is the length of the side adjacent to theta. Now, you also notice that if we keep the inside angle here, here, right here, and right here, the same thing holds true. And we're going to use that later. That's called a reference angle that we'll come back to. Now, the definitions of the trigonometric functions at any angle says let theta be any angle in standard position, and let P equal x of y, some point on the terminal side of theta. If the radius is the square root of x squared plus y squared, that's nothing more than a distance formula, by the way, from 0, 0, is the distance from 0, 0 to xy, as shown in figure 4.41 that we just looked at. The 6 trigonometric functions of theta are defined by the following ratios. Sine of theta is y over r. And by the way, guys, if you look at the triangle, all this is the sine, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. It's still just back to SOHCAHTOA looking at the triangles. But this lets us go back and attach that right triangle to the unit circle, or not just the unit circle, but the coordinate plane itself. Because once we throw in the r, we've thrown out the idea that it has to be a unit circle. The radius can be anything as long as we divide this. We're going to get the correct sign. Now, you're going to need to know these ratios. But once again, it kind of goes right back to the SOHCAHTOA, so you should be able to figure it out. All right, let P equal -3, -5 be a point on the terminal side of theta. Find each of the 6 trigonometric functions of theta. All right, so we've got the point on the terminal side right here. There's your x, there's your y. First thing we want to do is we want to find what r is. So r is going to be the square root of -3 squared plus -5 squared, which is going to be the square root of 9 plus 25, which is the square root of 34. All right, so that's your radius. So the sine of theta is going to be the y value, -5 over the square root of 34. And of course then you want to rationalize that, so you're going to multiply top and bottom by the square root of 34. So that's -5 square roots of 34 over 34. And cosine theta is going to be opposite over the hypotenuse, and that's going to be the x, which is going to be -3 over the square root of 34. And hopefully by now you can see what's going to happen here. So this is just going to be -3 square roots of 34 over 34. And the tangent is the y over the x, which is -5 over -3, which is 5/3. And then cosecant is nothing more than this thing right here flipped over. And remember, we don't want to go over here. We want to go back here before we rationalize, because if we flip this over, we don't have to worry about rationalizing. If we use this, we're going to end up with a square root on the bottom and have to rationalize again. So here we can just go back to here and get the square root of 34 over 5, and that is negative because of the -5. It's a negative overall value. Secant theta, same idea. We're going to go back on the cosine to right there. We're going to have negative square root of 34 over 3. And cotangent theta, I'm just going to flip this thing over and get 3/5. All right, evaluate, if possible, the sine function and the tangent function at the following 4 quadrantal angles. Now, quadrantal means we're going to end up dealing with the axes. So 0 degrees is the positive x-axis, 90 is the positive y. So when we say quadrantal, we're talking about one of the axes. So sine, if we're going straight out the x-axis here, whatever the x is also going to be the radius. What about the y though? Well, the y in that case is going to be 0. So for A, sine theta is going to be 0. Tangent theta is going to be y over x, which is going to be 0 over r. This would be over r as well. And both of those are going to simplify down to 0. Now with the second one, we're going in that direction, and we've got the sine of theta, once again, is y over r, and once again, whatever that value is also going to be the radius, because it's not going off at an angle. So however far in the y direction we go for a point, let's say we go to that point right there, not only is that the y value, but it's also the r value. So we end up with r, whatever it might be, over r, which is going to be 1. And for tangent, we're going to end up with r, which is the y. Well, let me write it this way. Y over x. And what's the y value? Well, the y value in this case is whatever r is. And what about the x? The x is 0. So that means it's undefined. All right, part C. We're doing 180 in this direction right here to some point out there. And then we do sine of theta. We're going to end up with what? Well, once again, we're going to end up with y over r. What's the y value here? 0, and whatever r is r. It's still going to be 0. And tangent of theta is going to be y over x, which is 0 over whatever the x value is, but in this case it's r. Remember the r here? And that's going to be 0 as well. Part D, 270, we're dealing with the negative the negative y-axis. We're going this direction down to some point that's r away. And the sine of this angle theta, 270, is going to be, once again, y over r, and tangent of theta is going to be y over x. So here the y is 1, or r, over r, which gives me a value of 1 for the sine. And for tangent, I've got r value is my y value, and my x value, I don't go either way from the y-axis, so that value is 0. So once again, it's undefined. Now, if you find tangent of 90 degrees and tangent of 270 with your calculator, it's going to give you an error, and depending on your calculator, it'll give it in a different way. It may say undefined, it may say domain or range error or domain error or something like that, because it doesn't actually exist. That value does not exist for a valid x value or a valid theta value. Now, if we look at the quadrants, remember the quadrants are the 4 parts of the coordinate plane. For quadrant 1, now remember, your sine is based off of your y value. Your cosine is based off of your x value. Your r is always going to be positive because we're taking the square root. And we're always going to look for a distance, and distance is always positive. So when we look in quadrant 1, we know our x values are positive and our y values are positive, so both sine and cosine are going to be positive. If both of those are positive, then all the derivations of those, the tangent, the cosecant, the secant, the cotangent, all those are positive as well. Now, when we get over into quadrant 2, what's going to happen? Well, my y value still stays positive, but my x value is now going to go into the negative x values. So I'm going to get negative x values, which means my cosine is going to be negative. And if my cosine is negative, then it's going to make cosine negative, it's going to make tangent negative, it's going to make secant negative, and it's going to make cotangent negative. So the only thing in quadrant 2 that are positive are sine and cosecant, because those are the ones that are based only on sine. When we drop into quadrant 3, we end up with both x value and now y value being negative. And when we get down into the quadrant 3, what do we know? Well, the only thing that's going to be positive are the ones where we're putting the two together. Sine and all of its derivations, cosecant, what I mean, are negative. Cosine and secant are going to be negative because all they are is reciprocals. The only thing that's going to be positive are the ones where we put them together, and we divide a negative by a negative. So that means tangent and cotangent are the only thing there that's going to be possible, or positive, sorry. So then we're going to move into quadrant 4, and in quadrant 4, my y value is still negative, but my x value is now positive again. What's based off of only the cosine, the x value? It's going to be the cosine and the secant. Everything else is going to have sine in it, and it's going to thus be negative. So that's how these work. So to remember, xy plus plus, negative plus, negative negative, and positive negative. There are the signs for the x and the y for all 4 quadrants, and from that you can figure out whether the sine is positive or negative, the cosine is positive or negative, and all those others are as well. And I have never used this in my life. If you want to use it, you can. That's fine, whatever. All right, finding the quadrant in which an angle lies. So if we have tangent theta is less than 0, so that's negative, and cosine is greater than 0, name the quadrant in which the angle lies. All right, so if the tangent is negative, that means we have a combination of plus minus or minus plus for our points. Because what do we know? The only way we can get a negative is a positive divided by a negative or a negative divided by a positive. So these limit our two situations to quadrant 2 and quadrant 1. Quadrant 4. Now, if cosine is less than 0, what does cosine go along with? Well, cosine is x. So if the x is less than 0, where is the x going to be less than 0? So this is quadrant 4. This is quadrant 2. And where cosine is greater than 0 is going to be where the x is positive, so that's going to be quadrant 1 and quadrant 4. Now, which one is in both lists? Well, quadrant 4, of course. So the angle theta for this situation lies in quadrant 4. So you just take it, find out where these things can occur, where this can occur, where this can occur, and then find out which one can give you both. All right, given that tangent theta is negative 2/3 and cosine is greater than 0, find cosine theta and cosecant theta. So we know tangent theta is negative 2/3. The tangent theta equals negative 2/3. And tangent theta, remember, is also y over x. So we're going to do the y over x, and we're going to split this thing into two parts. So the y is going to be 2 and the x is going to be 3. Now, which one gets the negative? Well, here's the thing. Cosine is greater than 0. Cosine, once again, pertains to the x. So the x value is greater than 0. That means the negative value has to go with a 2. So you can think of this as negative 2/3. Right? And that's where this point right here comes from. So now, once we've got that x is 3 and y is negative 2, we've got all these parts right here, remember? Now we need to find what the r is. So r is the square root of 3 squared plus negative 2 squared. So that's the square root of 9 plus 4, which is the square root of 13. And with the square root of 13 as our r, the cosine is going to be x over r, which is going to be 3 over the square root of 13. Rationalize is 3 square roots of 13. I don't like that. Over 13. And the cosecant, the cosecant is just the reciprocal of sine. Sine is y over r, so this is going to be r over y. So we end up with the square root of 13 over negative 2, or negative square root of 13 over 2. Now, We're also going to have to deal with angles that are greater than 360 or 2 pi, greater than 90 degrees, of course, and all negative angles by making use of the positive acute angle. Positive acute angle that we're going to use to find the values is called a reference angle. So what we're doing is we're taking the angle formed by the terminal side and the closest x-axis. That's going to be your reference angle. And then once you know what the reference angle is, you know what the sine and the cosine, or the x and the y value are. I keep saying sine and cosine and x and y. Just remember that the Greeks did not like you. They hated you. They wanted to make things difficult. Cosine's always x, sine's always y. So always flip those. Don't think that sine is x and cosine is y. That's not true. But we just always say x and y and sine and cosine, but it's mixed up. So make sure you understand that. And this positive acute angle is called the reference angle. Once we get those values, then we can use the quadrants to determine what the signs of those would be, the SIGN, positive or negative. So the definition of a reference angle is let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive angle theta prime formed by the terminal side of theta and the x-axis. The closest x-axis, either positive or negative. It's not always going to be the positive one. It's going to be the one that's closest to it. So it's always going to be ending up being an acute angle. If you try to get a reference angle and you've got an angle that's larger than 90, you don't have a reference angle. You have something else. So of course in quadrant 1 the reference angle is just going to be itself. In quadrant 2 it's going to be right here, and it's going to be found by taking 180 degrees and subtracting theta. So if we go all the way over here to 180 and we take away this theta, then we're left only with this part right here. That's our reference angle. If we've got an angle between 180 degrees and 270, then you're going to take that entire angle and subtract 180 from it, and that's going to leave you with this part right here, which is your reference angle. And if you've got an angle in quadrant 4, then all you're going to do is you're going to do 360 degrees minus that theta. So if we're going to go all the way around, but then we're going to take this part away, we're only left with the angle in here, the reference angle. So these three little rules you need to know how to subtract to find what the reference angle for a given angle is. Alright, so find the reference angle theta prime for each of the following angles. So if we've got 345 degrees, that's in quadrant 4. So in quadrant 4, I know I'm going to have 360 degrees minus 345 degrees. That gives me a reference angle, theta prime, of 15 degrees. Alright, part B, 5 pi over 6, that's going to be in quadrant 2. Quadrant 2, I'm going to have 180 degrees or pi, and I'm going to subtract my theta prime. So this is going to be 6 pi over 6 minus 5 pi over 6, which gives me pi over 6 as my reference angle. So theta prime equals pi over 6. Part C, I've got negative 135. So let's draw this one out. So we've got our angle here. We're going to go negative 90, negative 135. So we're going to be in quadrant 3 here. And we want this angle right here. Well, we've got this angle. You know, that's negative 135. How are we going to get that angle right there? Well, what you can do is you can go around the other way. Sorry, what you do is you're going to take the angle you've got here, so negative 135. You're going to subtract the closest x-axis, which is negative 180 degrees. So we're going to subtract negative 180. That's the same thing as adding, so we get a reference angle of 45 degrees. So those rules even work when we're going with negative angles. So the rules that we've talked about was for quadrant 2, 3, and 4 work even with negative angles. All right, and part D, if theta equals 2.5, well, let's think about what we've got on the unit circle. Notice this is not 2.5 pi, it's just 2.5. So we got pi over 2 here, pi here, 3 pi over 2 here, and 2 pi. Well, pi is 3.14. So what's 3.14 divided by 2? It's 1.57. So we know that that one is not in the first quadrant. 2.5 is going to be over here. We got 3.14, and 2.5 is between 1.57 and 3.14, so it's going to be in quadrant 2. So how do we find quadrant 2? Well, theta prime for quadrant 2 is just pi minus theta, which is 2.5, and you don't have to find the decimal. That right there is enough. So pi minus 2.5 is perfectly okay. That way you don't have to get into decimals and stuff like that. All right, another thing you can do with part C is you can solve it by finding a coterminal angle for negative 135 that's less than 360. It's between 0 and 360, so you could add 360 to it and get a positive angle. But it works even with negative angles. Now, finding reference angles that are greater than 360 degrees, or 2 pi, or less than negative 360 degrees, negative 2 pi, involves using coterminal angles. So you're going to add or subtract 2 pi or 360 to get it to be a coterminal angle between 0 and 360, and then use the rule that you've actually done, that we actually know, those 3 rules for quadrant 1, 2, and 3. So to find a reference angle for big angles or small angles, get a coterminal angle from 0 to 360, and then use that to find out what your reference angle is. So for instance, we had the angle 580 degrees, larger than 360. So I want to find a coterminal angle. I'm going to subtract 360. Right, if I subtract 360, I'm going to get 220. Six away from the 8 gives me 2. 3 from the 5 gives me 2, so 220 degrees. And then I can use that with my rules for quadrants 1, 2, and 3, or 2, 3, and 4, to find theta prime. Well, where is that? It's larger than 180, less than 270, so it's in quadrant 3. For quadrant 3, we know we're going to take the angle theta, and we're going to subtract 180. So we get a theta prime of 40 degrees. All right, part B, nothing changes. We still got 8 pi over 3. That's just our theta. And 3 goes into 8 more than 2 times, so we know it's larger than one circle. We're going to subtract 6 pi over 3. That's nothing more than 2 pi. Remember, I just go ahead and get my common denominator. You have to have a common denominator to subtract fractions. So 8 pi over 3 minus 6 pi over 3 gives me 2 pi over 3. And then to find theta prime, where is 2 pi over 3? Now let me show you a little trick here. We got 0, pi over 2, pi, 3 pi over 2, and then of course 2 pi. For some reason the pi throws people off. And here's what I want you to do. I want you to not think about the pi when you've got 2 pi over 3. Just think about 2/3. Where is 2/3 going to show up? Is it going to happen between 0 and 1/2? No. It's going to happen between 1/2 and pi? Yes. 2/3 falls in quadrant 2. So you're just checking to see what quadrant it is, just looking at the fractions, not worrying about the pi itself. If there's not a pi in it, that's another story. We already dealt with it, with an example of that. But if there is a pi, just kind of ignore it and look at the fractions. So 2 pi over 3 is in quadrant 2, and what's the rule for quadrant 2? We're going to have pi minus the angle theta to get theta prime. And to get this subtraction, I'm going to have common denominators, so I got 3 pi over 3 minus 2 pi over 3 gives me pi over 3. There is my reference angle. Alright, part C, we got negative 13 pi over 6. And we're going to add 2 pi. That's going to be 12 pi over 6. When I do that, I'm still going to end up with negative pi over 6. And I want a positive angle. So I'm going to go ahead and add it again. So I'm going to get 11 pi over 6. So then when I find theta prime, 11 pi over 6, 11 over 6 is almost 2. It's definitely larger than 3 halves, so it's going to be in quadrant 4. What's the rule for quadrant 4? Well, you go 2 pi, and you subtract your angle. So what do we need common denominator-wise here? 2 pi over 6, or sorry, 2 pi needs to be over 6's, so I'm going to do 12 pi over 6 minus 11 pi over 6, which gives me pi over 6 as my reference angle. Now, guys, once we know the reference angle, what we know is we know what we can use from quadrant 1 to find the sine value, the cosine value, all those trig function values, and we only have to go by what quadrant it's in as far as applying the SIGNs, the positive or the negatives, depending on which quadrant it's in. For instance, for this one, since theta prime is pi over 6, we would use the values that we get from pi over 6 for sine and cosine, but since it's in quadrant 4, we know that my x values are going to be positive and my y values are going to be negative. In other words, my cosine is going to be a positive value, my sine value is going to be negative, and that's going to trickle down through the other trig functions as well. Now, let's actually do one of these. Using reference angles to evaluate trig functions, the values of the trig functions for a given angle theta are the same as the values of the trigonometric functions of the reference angle theta prime, except possibly for the sine, SIGN. A function value of the acute angle theta prime is always positive. However, the same function value for theta may be positive or negative. For example, we can use a reference angle theta prime to obtain an exact value for the tangent of 120. Reference angle for theta equals 120 is theta prime equals 180 degrees minus 120 degrees, or 60 degrees. We know that the exact value of the tangent function for the reference angle tangent of 60 degrees is square root of 3. Now, if you don't know that, tangent of 60 is nothing more than the sine of 60 degrees over the cosine of 60 degrees. You can always fall back on those, and if you know these values, plug those in, you're going to end up with a square root of 3 over 2 over 1/2. When you divide, keep, change, flip, the 2's cancel out, and that's where we end up with a square root of 3. Now, we also know that the angle, that the value of the trigonometric function at a given angle theta is the same as that of its reference angle theta, except for possibly the SIGN, positive or negative. So we know that tangent of 120 degrees equals negative square root of 3 or positive square root of 3. What sign should we attach to pi over 3? A 120 degree angle lies in quadrant 2, where only the sine and cosecant are positive, everything else is negative. So sine's positive, cosine is negative, and we've got sine over cosine. So this is essentially the square root of 3 over 2 over negative 1/2, so that is negative square root of 3. All Alright, now a procedure for using reference angles to evaluate the trig functions is that you can find the trig function of any angle, theta, as follows. Find the associated reference angle, theta prime, and the function value for that theta prime. Once you know the function value for theta prime, it's going to be the same numerical value. The only difference is it's going to be a possible sign change, S-I-G-N. It may be negative, but the one you found would be positive. So you have to use the quadrant in which the theta, notice here it's theta, not theta prime, lies to prefix the appropriate sign to the function value of step 1. So theta is our original angle. Theta prime is going to be an angle that is in quadrant 1. Once we use theta prime to find the numerical value, we use theta and what quadrant it's in to find what the sign is, positive or negative, for all the different trig functions. So use reference angles to find the exact value of each of the following trigonometric functions. So part 1, or part A here, the sine of 135. So we're going to, theta is equal to 135. We're looking for theta prime. And that's going to be in quadrant 2. So in quadrant 2, we're going to have 180 degrees minus our theta, which in this case is 135 degrees, which gives us 45 degrees. Now, we want to know what the sine of 45 is. Well, the sine of theta prime, in this case the sine of 45, equals square root of 2 over 2. Now, we've got to be careful. That may not be the sine of a 135. That's where we've got to go back and use the original theta and determine what quadrant it's in. It may be the right answer, but it may change signs, S-I-G-N, as well. So in quadrant 2, which is where 135 is, here's 90, here's 180, so it's in this quadrant 2 here. Are the sine values positive or negative? Well, sine, remember, is your y value, and here y value is still above the x-axis, so it's still going to be positive. So the sine of theta, not theta prime, is also the square root of 2 over 2. So we don't have a sign change there. It doesn't change to a negative. All right, let's look at the cosine of 4 pi over 3. So part B, we've got the cosine of 4 pi over 3, which means we're dealing with theta being 4 pi over 3. And to find theta prime, where do we know 4 pi over 3 is? Once again, look at your fraction. Ignore the pi for a second. 4/3 is going to be larger than 1, but it's not as large as 1.5. So it's going to be in quadrant 3. So quadrant 3. And in quadrant 3, what do? We take our theta and we subtract pi. Not 2 pi, pi. So in this case, we're going to end up with 4 pi over 3 minus 3 pi over 3. That's pi with common denominators. And that means we're going to end up with pi over 3. So theta prime is pi over 3. So what is the cosine of pi over 3? Well, the cosine of pi over 3 is going to be 1/2. You should know that in some way, shape, form. Whatever memory tool you're going to use, you need to know that cosine and sine of all those key angles in quadrant 1, so it's 1/2. Now, is the cosine of 4 pi over 3 also 1/2, or do we have a sign change? Well, in quadrant 3, we know that both sine and cosine, both x and y, are negative, so we're guaranteed we're going to have a sign change in sine and cosine. So the cosine of 4 pi over 3 is negative 1/2. All right, let me clear all this out and get us another little space here. And let's do part C. The cotangent of negative pi over 3. Well, it's a negative angle, so theta equals negative pi over 3. Theta prime is going to equal, if negative pi over 3 is in quadrant 4, which it is, we know we're going to have 2 pi minus that right there. Alright, so in this case, instead of 2 pi, remember the closest x-axis if we're going negative is not 2 pi, it's actually 0. We're starting at 0 and going this way. We haven't gone all the way around to get to 2 pi. So it's 0. So it's 0 minus negative pi over 3, which is the same thing as pi over 3. That's what theta prime is. So when we find the cotangent of theta prime, we're going to end up with cotangent is nothing more than cosine of theta prime over sine of theta prime. So if we put in pi over 3, we've got the cosine of pi over 3 over the sine of pi over 3, and that's going to end up being 1/2 over square root of 3 over 2. Alright, so when we do that, we've got to simplify, so we're going to change flip. We got 1/2 times 2 over the square root of 3. The 2 is going to cancel out, and we end up with 1 over the square root of 3, which turns out when you rationalize, square root of 3 over 3. Now, is it going to be the correct sign? Well, what quadrant is negative pi over 3? Well, if we go negative pi over 3, that's in quadrant 4. And what do we know about cosine and sine? Are they the same signs or are they different signs? If they're the same signs, we've got a plus. If they're different signs and we divide, we're going to have a negative. So in quadrant 4, the cosine is positive and the sine is negative. The x is positive and the y is negative. Same thing. So we're going to end up with a negative and a positive. That's going to give us a negative. So we've got the cotangent of negative pi over 3, and that is negative square root of 3 over 2. Now, I'm not going to work these out, but I do want to look at them and show you. This is going to be very similar. You're just going to need to find an angle, a coterminal angle between negative or between 0 and 2 pi. So you're going to have to add or subtract 2 pi to these to get them down on the unit circle so that you can find a reference angle and all that stuff and find the values. It's nothing different than what we've done. Just get this in between. Just get a coterminal angle that's between 0 and 2 pi and solve it like you normally do. All right, that's all for this section.